Welcome to qnawire.
So problem number 17 says to repeat exercise number 16 for the particle in the first excited level. So in order to solve this, we need to look at problem number 16, which is, it gives you that, recall that psi squared dx is the probability of finding the particle that has a normalized wave function psi of x in the interval x to x plus dx. Consider a particle in a box with rigid walls at x equals 0 and x equals L. Let the particle be in the ground level and use psi sub n as given in equation 40.35. But for problem number 17, we're going to be looking in the first excited state. So part A asks for which values of x, if any, in the range from 0 to L is the probability of finding the particle 0. So first things first, let's write down the normalized wave function for a particle in a box. So this is equal to square root of 2 over L sine of n pi x over L. So now for this particular problem, we're interested in the first excited state. So n is equal to 2. So that gives us psi 2 of x is equal to the square root of 2 over L sine of 2 pi x over L. All right, so for part A, it wants to know what values of x at which the probability of finding the particle is 0 in the interval 0 to L. So that's what we want to know, is when this is equal to 0. Now, if wave function here, the probability of finding this function being 0 would be when the sine term, sine of 2 pi x over L, is equal to 0. So this only happens when 2 pi x, let me rewrite this a little bit better. So this happens when 2 pi x over L is equal to, we'll call it m pi. So basically, this m is some integer value where m is equal to 0, 1, 2, going on and on and on. So if you look, when the argument here is m is equal to 0, it becomes sine of 0, so this becomes 0, sine of 0 is 0. When it's 1, sine of pi is equal to 0, sine of 2 pi is equal to 0, and so on. So now what we want to do is we want to solve for what values of x that holds true, for that makes this true. So x is equal to, the pi's cancel, 2 comes over, so it would be ml over 2, or when x is equal to 0, L over 2, or L, because we want to know the interval from x equals 0 to x equals L. So these are the three values at which it would be equal to 0. Now it wants to know what values at which it would be maximum. So this holds when the sine term here in our wave function is equal to 1. So sine 2 pi x over L is equal to 1. So this happens when 2 pi x over L is equal to m pi over 2, half integers of pi, where m is some odd number, 1, 3. Actually, let me change this argument. It's plus or minus 1, because our probability is a squared, so sine squared, so this can be plus or minus 1. So 1, 3, 5, dot, dot, dot. So at m is equal to 1, it becomes sine of pi over 2, which is equal to 1. When m is equal to 3, it becomes sine of 3 pi over 2, which is minus 1. When m is 5, it becomes 5 pi over 2, which is 1. So now what we need to do is solve for what values of x that makes this true on our interval here. So those values are, so let's see, again, the pi's cancel. So x is equal to m L over 4, where M is equal to 1, 3, 5. So this is going to be, or otherwise, X, when X is equal to L over 4, and then 3L over 4. So again, on our interval x0 to L, these are the two values at which it's a maximum. So now part C wants you to compare it to the figure 40.12 to see if it agrees. So 40.12, so let's put part C, gives the probabilities of a particle in a box for different states. So we have, for n equals 1, we'll call that right here, n equals 1. It gives a probability function that looks something like this. Now for n equals 2, it gives a probability function that looks something like this. All right, so not the greatest drawing, but let's say right about here is L over 2, and these maximas. So if this is 0, this is L, this is psi of x squared. This would be L over 4, and this would be 3L over 4. So if you look, it has for the n equals 2 state, it has maximums at L over 4 and 3L over 4, and it has minimums at 0, L over 2, and L, just like in our what we found out here. So for minimum, it's 0, L over 2, L. For maximum, L over 4, 3L over 4. So that agrees with that. So the answer is yes. This agrees. With 40.12b. Okay.